Welcome everyone to the second of our seminars on the Internet of Things capstone project. Again, just to let you all know, just a reminder, these meetings are recorded and are posted to YouTube once they are complete, and I've had a chance to just clean up the edges and take out a few silent patches. The link is there. It's also on edX. You can subscribe to this channel and get alerted to any of the updates. All of the recordings of the sessions will be posted to this channel, so if you want to have a listen to some other people, their ideas and what we talked about, you're more than welcome to do so. They'll all be up there. Okay, so first of all, I'd just like to run through a couple of things that are needed for the next couple of weeks, which is what we'll talk about today, and then I hope we're going to get on to your questions and answers, discussions on what you're up to, anything you need help with, etc. We've been attempting to answer everyone's email on time. It's the beginning of our semester, so things have been a little bit hectic with our other teaching, but I hope we've got back to everyone. If not, let us know during the discussion time at the end of this short presentation, and we'll see what happened and hopefully answer any questions you do have. But we are trying to get to them within 2 working days, and I think we've got to everyone, but I may have missed something. I hope everyone is in teams. We've had a few people contact us about the discussion on which team should be in, but everyone, excuse me, everyone should be in a team. If you're still in a team all on your own, just check with us and see if we can find something that's fairly closely aligned to what you're doing. Okay, Carlos, I'll get to you in just a couple of secs. So remember that, please, Josh. If we can make sure that everyone's in a team and you've got at least 1 or 2 other people in there with you. If not, we'll work something out and put you into something that's close to what you want to work on. Now, one thing I'd like people to think about over the next week or so is discovering or coming up with a name for your device or solution. Coming up with a name, something that makes it a lot shorter than an automated snail tracking system for the home gardener. It helps you identify with it, helps you with the marketing, it makes it easier to communicate, makes it a little bit more personal too, so it can assist with the development of the system. So if we change it from our very long name about snail tracking to Sluggo, it becomes something that's a little bit more memorable, a little bit easier to identify with. Okay, so if we could try and come up with some imaginative names for your solutions, that'd be great. Okay, so this fortnight we should all be working on Canvanizer or having completed Canvanizer. I've seen a few really good ones so far. We'll be having a glance through those, but remember that you must also assess at least 2 of the Canvanizers of your fellow students. The reason we're doing this is to, well, number 1, we get some feedback to you on how your Canvanizer looks, but also by looking at the approach other people have taken, it could assist you in the development of your project.
That due date was yesterday, 5 PM our time in the end, so they should all be in by now.
Okay. Yep. If you haven't got it in yet, please let us know, and we can arrange. But we do need them in very, very well, on time or very, very soon, because we need to close it off and get the feedback to people. All right, so if you haven't got it in, please let us know and we'll work on that. Okay, so I'll still run through this little bit because it will help with the assessment of other people's. As I was saying, the idea we really want to get across, and the reason that we ask you to mark it, is we've got a very wide range of people involved in this project, in this course, and looking at the way other people from different skill sets approach the problem will actually help build your understanding of the different ways of doing things. So if we look at, say you're a very technical person and you're concentrating on how you can build the device, the software requirements, the hardware requirements, and you go off and you mark a person who is very business orientated and looking at the problem solution, how to market it, what market it holds, what the competition is. From their Canvanizer, you'll be able to pick up a lot of ideas that will help you build the business aspects into your project. And of course, the other way around, if you're a business person, you can look at some of the technical solutions that have been proposed and look at incorporating those into your final project plan. So things we'll be looking for, or asking you to look for, is the problem being well defined, top 3 problems for the IoT solution you're proposing. This is really important because it limits the scope creep. What we don't want to do is try and solve all the world's problems in one hit. There needs to be what is the problem that you're trying to solve, and that has to be very succinct and limited to a particular area. Make sure that they have identified the customer segments who they're going to target with that specific idea. The single compelling message about why the IoT idea is different and worth buying. So this is something that makes it different to all the competition, and that's kind of crucial when you're trying to get a new product out there. Channels, pass to customers. Cost structure is going to be very important. The cost structure is something that's fairly loosely defined, and you've really got to decide what you want to do with the cost structure. Most people look, well, this is going to cost me $50 to make, so I'm going to sell it for $75. Be very wary of that sort of structure on the costing. You really need to look at the competition. You need to look at the quantities of the market you'll be able to sell into, and include all your development time. So one of the most expensive things in any new product is actually the time you spend developing it. And the risk you take with developing a new product that may actually fail. So we need to include all of those costs and then look at the market and see where we should price the particular device. So if it's a market where there isn't a lot of competition, for example, everyone else is selling their device for $300, your device can do everything that theirs does, and you're making it for $10, there's little point in actually selling it for $20. If everyone else is selling at $300, look at pricing your product at the upper end of that, $250 to $260. This will maximize your return on the device and allow you to have sufficient income to look at further development, how you're going to have a roadmap for the device, keep it running, improve it, and increase your sales. However, that is a general commercial idea. If you're working on something that is more philanthropic, so we've got a group of people working on agricultural products for subsistence farmers, this is something that you really aren't doing for necessarily purely a money return. So in those cases, you look at all of your costs, work out how many of these you're going to sell, amortize your costs over the total number of devices you'd sell, and then add a small margin on top to cover warranty repairs, support, maintenance, looking at the next iteration of the device, etc. So in that case, if it was costing you $50 to produce a device, you might sell it for $75 to $100 rather than the $300 that other competitors are aiming at, because there is a philanthropic return rather than a monetary return. You've got to look at the revenue stream, make sure that the person on the Canvanizer has examined how they are going to get revenue from it. One of the ones that's really critically important for this project is the key metrics. This is how you can tell if your project is going to be successful or not. By setting up a series of milestones that you aim to reach at particular points, you can tell if you're on the right trajectory to complete the device on time, on budget, and within the specifications. Once you reach these metrics, you can actually tick them off, move on to the next one. If one of the milestones isn't met, you need to know why. You need to document why, so it doesn't happen again. And you need to find ways of meeting the milestone and either adjusting the later milestones or finding a way to meet those milestones in a more constrained time period. So key metrics on measuring whether something is successful is really, really crucial. We'll want to see those documented in your final report, how you set those metrics and how you actually met them and measured that you met them. And that should be part of the evaluation of the project in the final report. One of the key things, and we hope we won't run across it here, is the idea that with these metrics, they allow you to measure not only success, but also failure. There's a school of thought that says that we should fail fast and fail often. That may not sound good, but it's actually a really good way of working in this sort of area where you're trying new things. And it means that if you've got an idea, you try it out really quickly, you make a quick prototype or market assessment or whatever your particular way of testing it is. And if it looks like it's not going to work, you go, well, that was fun, let's drop it, move on to the next thing. And you do the same with the next thing. And that didn't work either, so we'll drop that and we'll move on to the next one. And this allows us to very quickly work out if something has a chance of succeeding and not wasting time on things that may not actually work out. So the fail fast, fail often paradigm is actually quite a good one to work with in cutting edge type and finally, look for the unfair advantage on the canvanizers you're marking. Again, this is going to be a very important part of the final report that you'll be writing, where you'll document what is the unfair advantage, how are you going to sell it, how are you going to meet the market in that final documentation. Okay, I'll actually skip over this one because we've all seen it. It's the snore stop from IoT1, and you should have something fairly similar done yourself, hopefully a little bit more detailed than this. So week 4 tasks, should have joined the topic team, of course, posted your idea, and I'm hoping that we're starting to get some discussion going between people within the groups. I've had a look through a couple of days ago, and yes, there's a few people quite active, which is great, but the idea in these discussion boards is exactly that. We want you to start discussing with your peers what you're up to, what questions you have, provide feedback on things that you like that they're doing, and equally give constructive criticism back on things that don't appear to be working, because it always pays to have that external view. We like when you go in and look at something that you're not particularly familiar with, you'll pick up items that the developer probably hasn't got. It's like when you're writing something. When you reread something you've written, you quite often read what you think you wrote, not what you actually wrote. So when you're working very closely in the development, you may overlook fairly obvious flaws to someone else. It really is helpful if you go and help other people, give them some feedback on what they're doing, and hopefully you'll get some feedback as well. Okay, by now we should have decided the web conference group we're in. Obviously we have, because you're all here. And there is a link to the WebEx. You don't have to rely on those calendar meetings anymore. Should have watched all the product development videos. I'll mention again that these videos that were posted by Todd and Nick, they are there to inform you on how to go about the development process. It's not really, well it is, but it's not necessarily about what the course is really about fully. Our aim for this course is somewhat different to the normal MOOCs, the MOOCs we've developed previously in this series. This one is all about getting a community together with some discipline type expertise from your advisors, discussing your problems and individually coming up with a development. So this is really more a virtual in-person MOOC, where we want the discussions to be live, email, through these sessions, etc., much closer to what you would have if you were physically attending a university. But these videos are a support structure, and we would like you to watch them. And please give us feedback on those too, if you don't mind. We want to know how they're going, because we want to use them in other things as well. Okay, so you should have submitted your Canvanizer link by now. This is the first grade assessment. It's worth 10% of your total mark. If you are having trouble submitting and getting the link posted, please let us know, because it is on 10%, but it's an important formative part of the course. We really want you to have a good idea of where you're heading, a good idea of all the aspects of the design you're going to have to go through, and it will help with that. Okay, what I'd really like to do now is open it up for discussion. We do want you joining in and driving what we do in these sessions, and that will become more so as we move further through the course, and particularly in the last 5 or 6 weeks. It will be all discussion. We won't actually be trying to present anything new to you. We won't be trying to push you along on certain things. It will be the development process. So absolutely key that you join in these discussions. I'll stop the seminar. This is all being recorded, and we'll hand over to Josh to see what questions we have and how we can start talking.
All right. I think Carlos had a question first, but after that, if anyone would like to talk, you can hover your mouse over your name on the participants window, and you should be able to click the raise hand button, the little hand symbol, and I'll come to you and ask you what your question is. If you're having trouble with your connection, the chat window is another option where you can type your question in there. You can send me the message if you like, and I can read it out to everyone. Carlos, did you have a question, was it earlier?
Someone type something in.
Oh, okay, I didn't actually see it.
Unfortunately, I can't see it.
All right. Anybody else who'd like to ask a question?
I've just put the IoT channel up so people can see where it is. The session today will be edited up hopefully by tonight, tomorrow at the very latest. Just takes a little bit of time to take the silences out and do a bit of noise cancelling, etc. So I'll do that as soon as I can.
Magditronics has a question. I'm not sure if you've got audio, microphone.
Yes.
You there?
Good morning first.
Morning.
Morning.
I need to ask about the first slide, Dr. The Prof. Aymari asked if anyone didn't receive an email for his answer. I need to know receive email for what?
Okay, so who was speaking? Sorry, Josh?
Magditronics.
Yes.
Yep. I'm just looking through the email. What email would you have sent that from?
I am from Egypt.
No. What was the email address you sent it from? I'm just looking for it now.
Yes.
Just to clarify, you sent an email that you were looking for an answer. Is that right, Magditronics?
Well, I can't speak. I can't listen to you. Sorry.
Siavash has repeated that in the chat window. If you have a look, we're just checking which email address. What name was it under?
I can't see the email.
Yes.
On my screen.
Okay. What?
I'll have a look at the chat screen. Okay. Because I can't find anything from Magditronics. But we need the actual email you sent it from, otherwise we can't find it.
Can we just check what was the name that you used on your email, please?
Okay. I will write in the chat.
Okay. Okay.
I need to ask another question.
Yes, go ahead.
For our ideas, if we have, if we need to discuss some technical problem, how can we do that?
The best way is to email the IoT Capstone project email address. If we can answer via email, we will. If it's necessary to arrange a Skype chat, like I think, Savash, we've got one straight after this. We've got a chat with someone straight after this. We will arrange it, but it's usually best to do it via email first. And unfortunately, I can't find your previous email. Would you mind resending it? Could you resend your previous email?
Yes.
Because I can't see it here, I'm afraid.
I write my email in the chat.
Yes, but I can't find an email from you. So if you could resend that, if something happened and it's not appearing, might have gone astray. Someone might have deleted it by accident. Don't know. Right, sorry about that. If you're not getting an answer within the 2 days, resend it, and that'll push it back to the top of our list again. Okay, so if you don't get a reply in 2 working days, send again, and that will remind us that we have missed it. We are trying to keep up to date with them, and hopefully it'll be well within 2 days. So send that through again, and we'll Okay, so if anyone else is having technical issues, email is the best way to contact the advisors. As I mentioned before, it's best to put the advisor's name in the subject or the topic. Now, back on our previous slides, we gave a little explanation of who's in what area. So if you're unsure, you can go back or just put the topic in the subject. Okay, Josh, somebody
Carlos
else?
does have a question. Can you hear us there, Carlos? And then we've got Jack after that.
Okay. Hello, can you hear me?
Yes, we can.
Yep.
Okay, well, hello to everybody. This is the first time I can join the meetings. Last time I had a problem with the difference in hours and all that. It was my mistake. My question is the following. I don't have any experience in regards to how to determine costs or anything related to the cost structure of a business or of a product. And one of the questions I have is, how do I determine the amount of the development costs that should go into the price of every unit I sell? Or if the thing is, I don't know if I need to plan for a certain amount, fixed amount of that cost in each unit, or if I have to plan to recover that investment in a certain amount of time.
Okay. There's a variety of ways you can do this, and it really depends on the structure of your business. If we're looking at a large company, it's much easier for them to work out the cost, because they will say the engineering department gets a budget of $10,000 for this product, and from that they've got to pay for their materials and their wages and their rent and overheads and everything else. The sales department will get another $10,000, and each of the departments involved would get a set budget. Their market research would then go off and say, we're going to sell 1 million of these devices. We've invested 10,000 here, 10,000 here, 10,000 here. So we divide our 1 million devices by the 30,000 items we're going to sell. We add that into the cost. You have your material cost, your assembly cost, your distribution costs, which are, again, fairly easy to come up with in everyone's case. And that is the end cost of your device. However, for people who are sole traders, entrepreneurs, just starting up, a lot of that cost has to be written off because it's a learning process. So in many cases, particularly with a couple of people with a great idea that they're trying to put together, all of the money they put in via their own time prior to having the prototype ready for production is written off. So if you're working within a registered company that you've just started, you would put that down as your initial capital investment. So whatever wages you pay yourself, the building rent, and that sort of thing, and hope to recoup it through your normal profits. Or you can go for a balance in between those two. So my suggestion in the case of our developments here, unless you're doing it as part of a company-funded project, is to say, right, the time I'm spent researching, the time I'm spending not working directly on the project, we won't count. But what we'll say is, I've invested X number of dollars in this edX course. I want that back from my product. I've spent however many hours you've spent actually working on the project. You can either put some of that cost in, or you can say, no, that's my initial investment, and throw it out. When you're working out your cost and you're actually documenting it, it probably would pay to state that I have written off the 14 weeks spent in development as my initial investment. I hope that answers your question, but the choice is really up to the environment. If it's a very controlled environment like a officially formed, long-running company, then it's very easy to get those establishment costs. If it's you working at home in the evenings, it's really hard to work out what they are, but you can take an estimate. Once you've actually got the material costs, then it becomes very simple. You add a margin onto the material costs, you add, look at how long it takes to assemble them at an hourly rate, and then you add whatever margin is applicable on the end.
Thank you very much, Professor.
All right, we've also got a question from Jack asking for a more detailed description of what is required for the final report. What will the format be and what needs to be included in it?
Right, I'm writing up a template which will basically be mostly just the headings of what's required, and perhaps with a couple of sentences within it describing what that section is about. But in a general term, what we will want to have is an introduction section, and this is describing pretty much what we've been talking about in the Kanban. What is the problem you're trying to solve? Why is that problem important? Why should it be solved? And generally, what your approach to it is. So that is to introduce, set the scene of what is going to be contained in the rest of the write-up. The next one is really the market research, and we'll go into that in some of the videos in a bit, fairly shortly actually. And that's knowing what the state of the competition is. So we need to know, is it something that is, you're going to be competing with a lot of other devices? If it is it just is it a mass market device? So if you've come up with a better version of Google Home, you've got lots and lots of competition, but is your device doing something much, much better than theirs, or is it much, much cheaper? So from that aspect, also knowing that nobody else is doing it. So this is the sort of thing you need to know before you go into the design. If nobody else is doing it, why aren't they doing it is probably a good thing to be looking at. Have people tried and it failed? Why did they fail? So the next section would be about how useful is this device? Is anyone else doing it? Are you going to have competition? If you are going to have competition, what differentiates your device from everyone else's? Could just be cost. You know, everyone else is selling it for $300 and you're selling it for $10. So you get that cost advantage. The next section is from the market research. You found out that the competition doesn't do certain things or doesn't do certain things well, but they do other things well. From that, you can work out what the design specifications of what your device is. So if we look at our snail tracker, we're working out how to track snails across the garden so that we can go around and collect them, not harm the snails and give them to our neighbour, because then they become his problem. The things that the current snail control systems don't do is look after the welfare of the snail. Right? They kill the snails. They're all baits or traps that will harm the animals. So the advantage is we're not going to hurt the snail. So we need to design our system so that it meets that lack that we've identified in the market research. So we're designing around the principle that everyone else hurts the snail and we don't. So from that market research, we found gaps in the market. We can then look at how we're going to control the snail population without doing any harm. And that's where we do our design section. Now, this design section can be either technical or business or a mix. Lots of us out here in this course are technical people. Lots of others are more business orientated. So if you're a technical person, you'll be talking more about the technical aspect, the technical design, the hardware specifications, the software specifications, and how you designed that section. If you're a business-orientated person, you do the same sort of thing, but aimed at the commercial realities. I know what I wanted to do. I don't know exactly how I'm going to do it, but this is how the product should work. This is how we're going to market the product. This is how we're going to cost the product. So that area would be the discussion of how you developed your solution to the problem. The next chapter or next section is on how you validated those design decisions. So in a technical aspect, you build a prototype, you tested if it actually could track the snails, and it tracked 67% of the snails, so it needs improvement, but this is the basis of how well it works at this point. So we need a section on how well your solution actually works. And then finally, we have sort of some conclusions, etc., and what the product is going to be in the longer term. So yes, you're going to have one out that tracks snails, but doesn't locate them. So our next step, the next improvement on the device will be working how to locate the snails after we've been tracking them. There are some other little bits and pieces that will go in there. I hope to have that structure up sometime next week, at worst the week after. But it will be there, and it will give you a reasonable sort of guidance. And then we can discuss that during these sessions if you're unsure about what goes in each part. I hope that sort of covers it, but it will be a document that you can follow. But use it as a guide. Don't use it as gospel. You can redo things how you think are more suitable for your particular market, your particular skill sets, as much in the way of images or text, whatever you feel happiest with. Is that an answer?
Yeah, he was on the text. Yeah, he's happy with your answer there. Thank you. Kevin has a question regarding the IoT platform. Do you have a microphone there, Kevin, or is it a general question about the IoT platform for the project?
Hello?
Yes, we can hear you.
Okay, perfect. Yeah, well, my question is about the platform for the project. I don't know exactly which option is better. I mean, if it's better to develop my own platform, like coding a web app with Python or any other programming language, or if it's better to use a third-party platform like for companies that offer like dashboards online where you can set up your dashboard fast.
Okay.
It's better for me. And because I've been trying to develop my own platform for the project in January, and that's the part that I found already complicated, because I don't know if it is better, or it's better to use a third-party platform or my own platform. I don't know.
Okay. So you're looking at the dashboard type platform, I assume? You're breaking up a little bit there. Here's one. I'll just share it. In all honesty, I think there's no single answer to that. Both building your own and using an established platform have advantages. My suggestion would be initially to use somebody else's system that I've used before, but I'll look for that while we're going on up later. Because if you use somebody else's, you've got simplicity. You can do the basic functions that you need to do very, very quickly and easily. Very quickly and easily. It may not be exactly what you want at the end, but you can check, you can do some user design, you get an idea of the data that's coming in, look at the data that's coming in to make sure it's correct and it's giving you the kind of things you'd really like at either no cost, low cost, and particularly at a low time investment. And time is the most expensive thing that we have. It is, when you're paying engineers or whether you're looking at your own time, it's really, really expensive. So anything that minimises time is good. Now, even though it may not be the best solutions for your, it will give you an idea of something that's going to work. You can get everything sort out the bugs, sort out the range of information you're getting, make sure that the information is actually at a level you need, you're sampling it often enough, it's accurate enough for what you need, and then move to a platform, a custom platform. I was just looking for what's the one we were using before? I don't think NAS is online, but Josh, you remember the one we were using in Myanmar?
You're not talking about Wiley Odrin?
No, the IoT platform.
Okay.
All right, I'll look that up and I'll get back to you. But we used one as a general platform. But there's so many out there that you can really just pick anyone that's free to use and have a shot at it. If that doesn't work, again, it's that fail quickly, and move on to the next one. They are fairly similar. Amazon's got one. Haven't tried the Google Cloud one. Just looking through a couple. Cisco has one which we could probably get a fair bit of use from. Anyway, we'll take the next question. I'll keep looking for the one that we used for that particular course.
All right. There's a question from Sharif. I believe he's writing it now in the chat window, so we'll read that when it comes. In the meanwhile, Siavash, you've got something to say?
Along the lines of what Ian just said, I wanted to add a kind of similar idea when you're choosing your hardware and microcontroller, because we've been getting a couple of emails asking which one should I choose, and I think the best way, especially when you're prototyping something, when you're starting out, is better to just use something off the shelf, whether it's an Arduino, it's a Raspberry Pi, or it's something that you're already familiar with. That's a better starting point. Then you can set up your whole system. You can always go back later on, choose a more specialized solution, hardware solution to what you currently have. But especially because it's supposed to be an IoT project, if you get that initial microcontroller, something off the shelf, something that's very readily available, then you can get the prototype made much sooner, and you can focus on more of the networking aspect and IoT aspect of it, rather than just being stuck working on a unique microcontroller that you don't have any experience with.
Yeah, that's a really good point. From a hardware perspective, it's best to use something that is off the shelf, easily, cheaply available. Usually would get something which is a little bit more powerful than you think you actually need, and then wind back when you're developing your own board. Because developing the hardware, custom hardware, is time-consuming, expensive, and if you don't design it 100% correctly the first time round, it becomes very expensive to actually fix. And the chance to design it first time round correctly, it doesn't happen often. But to give you an idea of what happens, if anyone's familiar with Arduino boards, they're about 3 inches long, 2 inches wide, 75 by 50 millimeters. Here's one that no doubt Siavash is well and truly familiar with. Yep, I'll get it in the camera. There we go. And that is the same as that Arduino board with all the excess peripherals taken off. Designed, is that one you, Siavash, or is that one's Weiyang, wasn't it?
Yeah, that's right. The one that Weiyang designed.
So designed by one of our PhD students here. So yes, you can get massive size reductions. You can have huge cost savings because we've taken all the extra ports and pins and connectors off it. But it's a pretty hefty investment to develop your own hardware. So particularly in this course, I think we're best sticking to off-the-shelf stuff and propose in that further development section of the report how you would go about designing your own hardware if that's suitable. And in many cases, it's not suitable. If you're looking at a fairly low-run device, like this one particular one that we've dealt with, which is home monitoring of dementia patients, and it has some artificial intelligence built in, machine learning, and it looks for things the patient is doing that is not normal. So if they're starting to open the fridge at 2 o'clock in the morning, it detects that sort of thing. Rather than develop their own hardware for this solution, it's Raspberry Pi, because a $30 Raspberry Pi turns out to be much, much cheaper than trying to build your own hardware platform that achieves the same thing as the Raspberry Pi. So why bother? If the off-the-shelf item does it, if the off-the-shelf item is cheap, use it. Anyway, I found the one I was thinking of. Is that showing up, Josh? Things board?
Yeah, that's there. Yes, we can see it.
That's the one that we were using, and it is really easy. It's open source, so once you've built something on ThingBoard, you can actually modify it and change it to suit your own product. But always remember, and this is something we'll go to in a little bit in the IP sections, if you take something that is open source, be very, very careful of the license that comes with it. Open source doesn't mean you can take it, change it, and then keep it to yourself. Most of the open source licensing means you can take it, change it, use it yourself, but you must make the source code available to everybody else, which means you can never copyright it, you can never protect your intellectual property that you invest into it, which is a good thing and a bad thing, depending how you look at it. But it does mean that you lose some of the investment you put into these changes. I prefer to use everything open source because I'm a share and caring kind of guy. No, seriously, I'm already working for a university, so I don't worry particularly about the intellectual property. If you do go for something that is under the GNU public license or similar, be aware that anything you do will be public domain as well. All right, so that's the reason to use closed source if you want to keep things to yourself. But you will have to pay a fee for that, of course, whereas these are free. But this is quite a good one.
We don't have the questions, Sharif. Oh, it's just appeared now. That's good timing. Right, so you can see the question there. He says, as I am working on home automation, my idea was controlling appliances using Wi-Fi signal strength or using Wi-Fi triangulation systems. If AI can get a location of any person on certain places, can we control the appliances near to that person using Node MCU? If it is possible, can you please share me some keywords so that I can look that up in journals to get a clear idea? Thank you, he says.
Okay, that will require a little bit of thought, so I'm going to make a note of this and get back to a little bit of it. But your idea of using the signal strength is good. Just be aware that it's very, very inaccurate. Signal strength is affected by multi-part properties, the fading, the signals you get through walls changes. One thing you might want to build into it is the building a Wi-Fi fingerprint. Now, this requires you to go and do a bit of a survey first, or you can build it up as the person moves around. And you basically build up a map of the signal strength by measuring it, walking through, knowing where you are, entering locations, so that you can actually map the signal strength from those interference things like multipath and walls and those effects. And it gives you a map of the signal strength throughout the building. But it does require you to go and do a survey first. So you have to mark where you are. Triangulation is great, except if we're looking at a home automation, you need at least 3 points to be able to measure or locate where you are. And a lot of people don't have multiple beacons. You have to be using fixed point wireless access devices to work out your location. But triangulation actually is much more accurate. Particularly, you have to know where the physical location of each of the wireless devices are. Just going back to your question there. Okay, I'll have a look at the Node MCU. I'm not overly familiar with that. Are you, Savash?
No, I don't have any experience with that.
Let me just go and have a quick look if we've got something. But we'll email you back on that one.
All right, any other questions from someone in the meantime, either on the microphone or the chat window?
Oh, okay, Savash, it's hang on, I'll share it here. Arduino-based wireless. Okay. Node MCU, ESP280. Okay, so just a hardware wireless device.
Oh, I see. I'm just looking at it as well. Yeah, these are fairly popular with IoT projects. The newer versions include they're ESP32s. They're essentially a more updated version of the same chip. They're not that bad. The only I guess problem might be they're a bit finicky to work with. Initially, there are Arduino cores for them, so you can just use Arduino programmers to program them. I would say it's probably easier to start with something that's just based on Arduino, something similar with a Wi-Fi built on top of it. But if you're keen on using something like that, I would say probably if you want to use something specialized like that, use the newer version. I'll type the name here, and I can probably share an AliExpress link just to get an idea how similar the boards are. So that will give you a good start.
I think what I'll do is, if we go and have a look. Okay, Sharif, we'll go through and have a look at your Canvanizer link, and I'll figure out some keywords on that to send through to you. If you do find a journal that you can't get, let us know and we can probably grab a copy from our library for you. All right, so we'll get back to you on that one once I've seen a little bit more on how you want to use it within your application.
All right. He says thank you. So anybody else who'd like to discuss or ask a question? Well, we have some time left.
Hello.
Yes, someone. Kevin. Yes.
Yes, I have another question about the timing of a project. I mean, what factors should I consider when setting up my frame time in a common IoT project during the development?
Okay. That broke up a little bit for me. Josh, did you get the question?
No, I didn't quite catch the. Could you just repeat that, please, Kevin?
Yes. What factors should I consider when developing, let's say, a common IoT project? What things should I consider when I want to setting up a frame time for the development of a common IoT project?
Okay, Josh, you'll have to excuse me. My hearing is not very good, and that broke up a little bit. Did you get that?
The platform to use to develop an IoT. I think it was related to the platform. Sorry, it's quite a bad.
Okay, I will write the question.
You get a Savash? Yeah, it's a bad line. Is there any chance you could type that in for us?
All right.
Sorry about that, but
he's typing
my
that
hearing's not breaking.
Yeah,
oh, excellent.
We'll get to that once that's typed in. And in the meantime, R. Holly says he's been using ESP32.
Yep, that's a good platform.
And Sivash, just after that, has more information on ESP32.
Yeah.
The AliExpress link he was talking about.
Yep. ESP32s tend to be quite popular. Our students absolutely love them. They're cheap, they're powerful, they have lots of I/O. So when choosing a platform at the prototype stage, it really isn't that critical. The critical part comes in when you want to reduce the costs down to the absolute minimum you need to achieve your goal. So that's when you start looking at the too powerful. Can we move to something cheaper, smaller, lower power consumption, and less I/O? So at this point, it's really a case of looking at a very general level. What are you doing? How many inputs do you need to the hardware? So how many digital I/Os, how many analog I/Os, how big is the program going to be? Not worried too much about the speed of the processor, because you can always get one that's just faster with the same I/O. But making sure that you've got enough pins to read things in, you've got enough memory to program, enough memory to store your data. So having a good estimate of those requirements, and then just buy anything that fits. when you go through the production level, then you would look at tailoring it a little bit more closely. One thing we haven't touched on a great deal here is power requirements. Power requirements are going to be a crucial part of anyone who's doing a hardware design. We use Raspberry Pis a lot for our projects, but they are truly awful on their power consumption. They burn 5, 7 watts depending on the model, and when you're running off a battery, that's a lot. If you compare that to some of the very low power processors, Savash will be able to quote magic figures probably if he wants to pipe in at any time, but MSP 430s and some of the other ultra low power devices draw microamps instead of amps, so millionths of an amp rather than full amps. And that will make a huge difference to the life of the device, because the last thing you want to do, particularly in an industrial setting, is have a factory covered with 6,000 odd sensors and have to hire 5 full-time people to run around changing batteries all the time. So power consumption is really, really important on these devices. So look at how much power it draws, how long you want it to run between battery changes, or if you use a source like a solar panel or wind turbine, because you can make them really small, to actually keep topping the battery up. Any comments on power, Savash?
Honestly, I don't remember the exact numbers, but I'm from when I work with ESP32, I know that they are pretty power hungry, because especially some of the ESP32 micros and development boards, they have the dual core processors on them, so that makes them fairly power hungry. So if your project involves something like that, I would be wary of choosing ESP32. And one more thing about these sorts of devices is ESP32 is very new and interesting, and there's a kind of a buzz in the community around, especially in IoT projects. But most of the development boards that are available for it, they're unofficial, and the ones that are available from the manufacturer of ESP32 itself are fairly expensive. So if you don't have that experience, it might still go with something. If you just go with an Arduino and a Wi-Fi or Bluetooth module added on top of it, it would be still cheaper than going with an ESP32, and it would require less power and will have more of a robust kind of background information, more open source software around it. But if you are interested in kind of working with the newest thing, yeah, ESP32 is fairly good. Just look at the different modules, because they do have quite different variations of them that they produce to market. So make sure to choose one that suits your project needs.
Yeah, that's good. As this also ties back into that fail fast, fail often. If you try a processor and it doesn't work and it's off the shelf, no problem. Throw it out, get another one. This sort of prototyping stage is better to test ideas, not test hardware. So you want to see if your idea is going to work, and that I think if the idea is going to work, well, we can fix all the details later. But rather than spending all this time trying to get the platform right and then finding out the idea doesn't work, that's a huge waste of time. So the platform is of much lesser importance than proving whether it works or not, proof of concept. And once you've got the proof of concept that's going to work, then you spend the time investing into which platform I'm going to use, is it the most efficient platform, etc.
And that relates to what Kevin was asking when we couldn't quite hear him, asking about the time frame. So what factors should he consider when setting up a common IoT project in relation to the time frame?
Yeah.
Setting up the time frame for a common IoT
Yeah, project. I think it's very much make sure your idea is going to work first and then go into detail. So once you know that I'm running this on a Raspberry Pi and the idea is working and it's giving me the information I want, but I could actually run on an Arduino, well, then you change back to the ESP32 or whatever chipset you want to use, but confirming the idea first.
All right, so does that answer your question, Kevin, regarding the time frame? Any other? hopefully so. We've got a couple of minutes. If there's anyone else who has anything.
Okay. I think that's all I had. All right. Just remember, if in doubt, email. If you don't get a reply in 2 days, email again, because it just means we've got snowed under and it's been pushed too far down the stack for us to see. Don't be shy about sending those emails. We're quite happy, most of us, to talk to you. And as I said, if need be, if we can't solve it in email, I'll let you know my Skype address and we'll have a bit of a chat. I've got a couple coming up shortly on that. So also happy within reason to have individual sessions with people if they're really stuck. But we do have limited time, so just bear that in mind.
So speaking of the Skype call, Ian, I just added you on Skype. So are we having that quick meeting after that with the student afterwards?
Okay, well, if there is no other questions, good luck, keep working at it. Any questions, email us, and I look forward to having a read through the Canvanizer. Some beauty so far. I mentioned it last week, my favourite, the horse monitor. It's a really interesting idea that you monitor the health of a horse, and it's got some very easy challenges, such as looking at the horse body temperature, the breathing, the heart rate, but he's got some really, really interesting challenges coming up, because one of the things I want to know is the colour of the horse's mucus. So we've got to work out a way of detecting the colour of horse mucus. Interesting. I'm glad I'm not doing it in person, but so these are the kind of interesting things you can actually get up to. It's going to be fun. All right, then. We shall speak to you in 2 weeks again, if not sooner. Thanks for coming along.
Yeah, thanks, everyone.
Thank you very much.